one orchestra, one performance. From it, a single number, the balance of the whole ensemble. Play the night again, with the very same players, and that number would drift a little. The honest question is how much, and we are only given tonight. There is a way to ask without a second concert. The conductor silences one chair, and listens, restores it, and silences the next. With 100 players, that is 100 performances, each missing a single voice. Repeat it tomorrow, and the same 100 answers return. Nothing is left to chance. Each silence exposes a player's leverage, how much that one voice was holding up the sound, but muting 1 in 100 barely moves the meter, so we amplify it, scaling the gap by n-1, and recover that player's true weight. We call it the pseudo-value. Now take all of those leave one out readings and measure how widely they scatter about their average. That scatter, scaled the same way, is the Jackknife's estimate of how far our number could wobble. One formula, and the same result every single time. The second way is bolder. Dismiss the roster, and assemble a new orchestra of the same size, but choose its players at random, with replacement, from the ones who showed up tonight. Now a chair may hold a familiar face twice over, the same cellist, drawn into 2 seats, and some who played tonight are not called at all. How many sit out? For each new draw, the chance any one player goes uncalled settles near 1/e, about 37 in 100. So every reseated orchestra quietly leaves roughly a third of tonight's musicians in the wings. Stage not one such orchestra, but 1,000. Each plays, each gives its own balance. Lay those 1,000 numbers side by side, and a shape appears, the full range of concerts the night might have produced. Draw the 1,000 again, and the shape shifts, just slightly. This way trades certainty for imagination. From that shape, the answers fall out directly. The spread of the 1,000 balances is our standard error, and the values 2.5% in from each end mark a 95% interval. Read straight off the distribution, no formula required. Now change the question. Suppose the number we care about is not the average, but the median voice, the pitch sitting exactly in the middle of the ensemble. Silence any single player, and the middle barely stirs. So the muting method hears almost nothing, and reports a wobble near 0, but it is wrong. Reseat the orchestra 1,000 times, and the median jumps about, plainly inaudibly. When the number bends smoothly, both methods agree. When it moves in steps, only the bolder one hears the truth. 2 philosophies, then. One asks what each musician is worth, exactly, and the same way twice, quick, certain, and blind to anything but a smooth response. The other rebuilds the whole orchestra again and again, hearing the full chorus of what might have been richer, but never the same answer twice. Neither is simply better, they answer different questions. 2 empty chairs, in a quiet hall. One method removes a voice to learn its weight, the other imagines new players to learn the room. Both, in the end, are asking the same gentle question: how sure are we, really?